Welcome to the class of engineering mechanics. In the last class we have discussed about how center of gravity has to be determined. So in the last class we have determined a T-section structure and find out its CG. Now let's start with a I-section with different flange, right? So I am taking this I-section. This portion is called flange, this portion is called flange, and this is wave portion, right? The dimension of the upper flange is given 150 millimeter. The depth of the upper flange is 50 millimeter. The depth of the bottom flange is 100 millimeter and the width of the bottom flange is 300 millimeter, and total overall depth of this I-section is 450 millimeter. So this is the given problem, right? We have to find out the CG of this I-section. So at first we have to calculate what is the depth of the wave portion. So this is 50, this is 100, so this is how much? This will be 100 plus 50, that is 150, and the overall depth is 450, so 450 minus 150, so that means 300 millimeter. Okay, the question is find out CG. So similarly we divided this structure into three parts. This is 1, this is 2, and this is 3. So for the one section, that means for the bottom flange, what will be its area? We symbolize as A1. A1 is how much? 300 into 100. That means it comes out millimeter square. Okay. Now we have to, and we take this baseline as the reference line. So our y1 is equal to 100 divided by 2, that means 50 millimeter. Now take the wave portion. This is for bottom flange. Okay. Now for the number 2 section is wave. In case of wave, what will be our A2? A2 is this portion and this portion. Okay. Take this, the thickness of the wave is 50 millimeter. Okay. This will be given in your problem, the thickness of the wave. So the thickness of the wave is 50 and the depth of the wave is 300. So 300 into 50. This is your area of the wave. That means 15,000 millimeter square. And what will be your y2? Y2 will be how much? From this one to this one. So this one is 100 plus 300 divided by 2. That means 100 plus 300 divided by 2. This is 150. 150 plus 100 is equal to 250 millimeter. Right? So bottom flange is done, wave portion is done. Next move on to the top flange. Number 3. Number 3 is for top flange. In case of top flange, what will be our area? 150 into 50, right? So A3 will be 150 plus 50, that means 7500 millimeter square. And what will be Y3? Simple, look at this figure. Y3 will be this distance, so this is 100, this is 300, so 400 plus this is 50 by 2, that means 25. You can similarly solve from upper portion also, that is total is 450 and this is half portion, that means 25, so 450 minus 25. So as we take baseline from the bottom line, so 100 plus 300 plus 50 by 2, that is how much? This is 400 and this is 25, so 425 millimeters. So we know what is our A1, A2, A3 and as well as Y1, Y2, Y3. So similarly, the CG of this figure. Okay, from the bottom branch we can calculate Y bar is equal to the similar formula, A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3, right? So put that value of A1 Y1, A2 Y2 and A3 Y3. So A1 was into Y1 was how much? Y1 was 50, A2 was 15,000 and Y2 was 250, right? So Y1 was 50 plus A2 was how much? 15,000 into Y2 was 250 plus A3 was 7500 into Y3 is 425 divided by A1 plus A2 plus A3. A1 is A2 is 106 extra and A3 is 7500. So if we calculate, value comes 160.7 millimeter. Try to solve yourself this type of problem and calculate yourself, so you can learn easily. And similarly we can solve a angle section also, and this is your homework for the assignment purpose. Try to solve a L section, or you can say this as angle section. Okay, the angle section having longer side has 150 millimeter length and shorter length is, take it as 80 millimeter, and take both thickness of this shorter span and longer span is 20 millimeters, and this one is 20 millimeters also. Find out its CG. Okay, in this case direction for major axis as well as for minor axis, that means you have to find out X bar and as well as Y bar. Okay, try to solve yourself. If you go through the basic fundamental, you can solve it is very much easily. Okay, that's all for today class now. Thank you.